So I have these two parts here. I have the momentum of this plus the momentum of that. Now there's a lot fancier ways of doing this, but the simplest to find the total. Actually, somebody tell me, what's the simplest way to get a total here? Yeah. So I think, be careful what you do though. Don't go too far. 8,000 kilogram meters per second I hat plus 6,000 kilogram meters per second J hat. Done.
So you can't simplify that?
This is called rectangular form. There is something called polar form, which involves using trig. So this really is.
So that's an acceptable answer to
Yeah,
Blaine?
absolutely.
All right, awesome, thank you.
Kimberly?
When I went to tutoring, he told me to use the Pythagorean theorem.
Okay, so that's another part to it. Because. Isabel? Yeah. Borrow this for a second. What is the final momentum of the combined rect? Okay. Because I'm asking for the momentum, I'm not asking for magnitude of momentum, I'm just asking for momentum. Momentum is a vector, so we do need to have somehow have direction in it. Now V is what's the magnitude of the final velocity. The Pythagorean theorem is going to come into it at that point because we're asking for just the magnitude. I see two hands up. Why don't I just start here and work my way back? Scott?
You said be careful what you do, like, how can you mess up total?
If I have 8,000 units I hat plus 6,000 units J hat, I've had enough students to make that 14,000, and it's not.
Okay, so, like you already said, that is the simplified.
Yes, right there.
Thank you.
All right, and Isabella?
You just go ahead and do part B.
Okay. Lydia?
Does it matter if you put like J at, or like, in this case, 6,000 before 8,000? It doesn't
It
matter?
does not matter.
Okay.
Commutative property holds. It doesn't matter the order when you have it. All right. Other questions on part A before we do part B?
So to answer the final momentum, we just write that down, that whole thing?
Yes, I'm using different numbers,
Yeah.
but yes.
Okay.
Yeah, this. Circle it and done.
Alright.
I have a question, but I don't know if you want to answer this one or part B first, because she asked first. But, question 3 is similar to question 4, but it has them going north and south instead of like north and east.
Right, that one, because that's a one-dimensional problem, you can define which way is positive and get away with just plus and minus.
Oh, okay.
So
Awesome.
that's one where you can combine them because they're both in a line.
Thank you.
Or combine them easily, I should say. All right, there was a request to talk about part B, which was the final velocity, because they perfectly inelastic collision, I believe. They combine, stick together. All right, so I know that's equal to the mass times the velocity. Final mass, final velocity. They're one object now because they stick together, so that's why I don't have to have other subscripts for the mass and the velocity other than just the final. Well, what's the final mass?
Would it be 4,000?
Lost my problem here. Yes, it would be. Because there are now one, I have 2,000 and 2,000. I have now 4,000. So I have 8,000 kilogram meters per second I hat plus 6,000 kilogram meters per second J hat is equal to 4,000 kilograms times whatever my final velocity is. Now the question is asking what's the magnitude of the final velocity. There's more than one way of doing it, but I'm going to do it this way first, then I'll do it a slightly different way to get to the same place. This is my unknown here. I need to get it by itself, so in math class, what do you do when you wanna get something isolated? So we will, I'm dividing this by 4,000 kilograms. I'm dividing over here by 4,000 kilograms. Lydia?
So just to clarify, you got the math and just adding the two?
Yes,
Oh, okay.
because they combined, they became one.
Okay.
It was a beautiful thing. When two cars love each other very much. Now, when you're dividing, I got this, I have two terms here divided by a single common factor. Despite what some students have tried to push off, you're gonna divide both of these by 4,000. You're not dividing just this by 4,000 or just that by 4,000. So 8,000 divided by 4,000 is?
2,000.
Two.
Yes, 2. I have 2 meters per second I hat. And then 6,000 divided by 4,000. 1.5 meters per second. So that's my final velocity. We haven't answered the question yet, but that's just a step. Now the magnitude, this is when Pythagorean theorem comes in at this point for this technique. We'll get Pythagorean theorem a little bit earlier the second time I do this. But I'm going to the right 2, I go up 1.5. And so the magnitude is the size of my resultant. There's my resultant right there, or my final speed is that length. So 2 squared plus 1.5 squared is equal to v final squared.
6.25.
Is equal to v final squared, and then v final is the square root of that. What is it?
2.5.
2.5. So 2.5 meters per second is the magnitude of the final velocity, or the speed. Or I could have also asked how fast is it going?
So you only use the Pythagorean theorem when you're looking for the magnitude?
My gut was yes. There's some exceptions that are running through my head right now, but I'm not sure those exceptions show up in Physics 110. So, for the most part, yes. Let me hedge my bet there. Lydia?
Do you just want the first decimal place, or how much?
Well, in this one, it happens to come out nicely,
Okay.
but, yeah, 2 sig figs for those who've dealt with it. 1 decimal place there is fine. 2 non-zero numbers. All right, questions about this, I'm gonna do it slightly differently. I suspect that, Kimberly, you did Pythagorean theorem with the 8,000 and the 6,000?
Yeah, that's what Mike told us.
Okay. But we'll do it again, doing Pythagorean theorem at that point, and show how we get to the exact same place. Any questions about what I did here before I doing Pythagorean theorems a little bit earlier? All right. It's dawned on me, we have a new eraser.
Sir.
Yes.
It's kind of about that, but at the beginning of the problem, do we have to clarify our positives and our do we have to clarify J hat and I hat?
If I'm expressing the answer using I hat, if I'm putting I hat and J hat in my final answer, I do need to say what I hat and J hat are.
Okay.
And I hat is not automatically that way, J hat's not automatically that way.
Okay, cool.
Think of yourself as a goddess and you get to decide.
Oh, I already do.
All right. Other questions before I turn my back on you?
It doesn't have to be about this, right?
Pardon?
It doesn't have to be about this question, right?
I'm gonna do one other part to this question. So any other questions on this one for right now.
Where did the 4,000 come from?
The total mass, that momentum is mass times velocity. In this particular problem, they crash and stick together. So the total mass is the combined mass. Because I had 2,000 kilograms and 2,000 kilograms. Is that sufficient?
Yes, sir.
Okay. Other questions? Luis?
Okay, so I understand everything from over there, but I got confused right here with the 2 meters per second. Yeah, and downwards.
All right.
Like that.
So you're not sure where I got the 2 from?
No.
Okay. So I got this 8,000 I hat and 6,000 J hat. This bit right here, because when I wanted to get rid of the 4,000, I divided by it. When I divide by it, I have to divide everything by it. So that becomes 8,000 I hat over 4,000 plus 6,000 J hat over 4,000 is equal to my V final. That's where that's coming from, because when I divide by 4,000, I divide this by 4,000, that by 4,000, and this by 4,000.
Okay.
And so 8,000 over 4,000 is the 2, and then 6,000 over 4,000 is the 1.5.
Oh, okay. All right.
All right. Now, do you want me to keep going?
No, I think so.
That was, okay. Other questions on what I have on the board right now? What we have on the board, it's a collaboration. Any questions on this before I erase some of it? Got that. All right, so this was my final momentum, but I could have also found my final speed by finding my magnitude of my momentum first. So let's do Pythagorean theorem at this point, find out the magnitude of my total momentum, and then find the final speed. So I have 8,000 going to the right, and I have 6,000 going up. That gives me a right triangle, because I had J hat are perpendicular. So let's find the magnitude of the total momentum. So 6,000 squared plus 8,000 squared is equal to my momentum squared, or R squared, or whatever letter you happen to use. I think P comes out to be 10,000.
Yeah.
So that's the magnitude of my momentum, and that's got to be equal to my mass times my speed. It's one object, so what direction, the direction of my velocity has got to be the same as my momentum. Because it's just one object, I have 10,000 is equal to mass times speed, so 10,000 is equal to 4,000, because that's my mass now, times my speed. Divide by 4,000, and you get 2.5. The advantage of this technique right here is that it gets rid of the I hat and J hat earlier. The disadvantage is I've had too many students in the past gets to this point and call that the answer when what I was asking for the first part was this. I feel like when the student takes a picture, I should do a Carol Merrill. A brand new car.
Mr. When I got 6,000 squared, plus 8,000 squared, and then I got the square root of that, I got 8,000. Or wasn't I supposed to?
So that's something's off. 6,000 squared plus 8,000 squared is not 8,000 squared.
Well, not 8,000 squared, but I like square root of whatever I got equals to.
Yeah, something's off. So, yeah, the equals first, then the square root. I apologize. With your own free will, you can do it differently. Yeah, you needed to get to get the correct answer, you needed to get the sum first and then do the square root.
Okay.
That was the issue.
And I fully,
That's why you're the teacher.
Pardon?
So that's why you're the teacher.
Sure. I'd like to think I did a little bit more than that to get here, but, you know, hey. There's some mysterious process. All right, questions about this problem before Isabella asks her question about something else? All right, Isabella, what was your other question?
Number 5 specifically
5D. One-dimensional problem, two boxes headed towards each other. Box A has a mass of 20 kilograms. All right, so we have these things heading towards each other, different masses. Okay. So it's conservation of momentum problem. So, as before, I'll just make up numbers or give it a little imagination, I might come up with the exact same numbers. So let's make this 2 kilogram box going at 6 meters per second. And the other one, I gave the velocity as a negative value, which means it's going opposite the direction of the first one. So I'm just gonna make it to the right positive. It's a one-dimensional problem, so I can get away with just that. If you really love the I-hats or J-hats, if you want the unit vector in there, go for it, but not necessary in a one-dimensional problem. But we do need to establish a positive direction. 5 kilograms heading back this way at 3 meters per second. So part B, I gave the velocity of one of them afterwards. And so this is before. Then after, let's just say that 5 kilogram is going to the right at 1 meter per second afterwards. And what's this one doing?
Since, the 3 meters per second is going that way, should it be negative, or is it still?
Yeah, all right. So it is, the velocity is indeed negative, you're absolutely right. And when we plug in to figure out the momentum, don't forget the negative sign. The negative is telling us direction, and I indicated direction here by an arrow. So if I did -3 with an arrow to the left, that really officially means it's going that way. So that's why I did it that way. I could have just as easily done 5 going to the right at -3. Negative just means, hey, other way. Other questions before we plunge in? Then let's plunge away. All right, it's a conservation of momentum problem. I need to figure out my momentum beforehand, and that tells me what my total is afterwards. So what is the momentum of this 2 kilogram mass before the collision?
12 kilograms meters per second.
All right. Because I don't feel like writing that unit over and over again, we just do the shortcut here. All right. And divide it up there. All right, what's the momentum of this one before the collision?
15. 15 kilograms times mass of, or meters per square.
Didn't quite hear the full unit that you just said, but I think I probably misheard some stuff. That's not the biggest issue I have right now.
Negative.
Yes, it's negative.
Oh.
Negative 15 units. So therefore, what is my initial total momentum?
Negative 3.
Then what's my total momentum after they collide?
Negative 3.
Yes. So conservation means in physics, the same, get the same total before and after. Well, I mean, my total is negative 3. What is this one after the collision? Just this one piece. Ethan, it looked like you mounted it.
5?
Yeah. In units.
How would you find it? Oh, 5 times 1.
Yeah. So the question is, what is the momentum of this 2 kilogram mass in order for my total to be negative 3? Yes. From a math point of view, I'll just call this x. Basically, I'm dealing with x plus 5 is equal to negative 3. That's the math problem. So this momentum has to be negative 8 units. And that's got to be equal to the mass times its velocity. So 2 kilograms times its final velocity is equal to negative 8. So what is the final velocity of this 2 kilogram mass? Isabel, question and answer?
That's the part that confused me when I read it the first time. You just backed up and explained where you got the x plus 5